Complex numbers. Question number 1. If Z and W are two non-zero complex numbers where modulus ZW is equal to 1 and argz minus rw equal to pi, then Z bar W is. Let's see the solution. Let Z equal to R1 times cos theta plus iota sine theta and W equal to R2 cos phi plus iota sine phi. Now we are given modulus ZW equal to 1, which implies modulus Z modulus W equal to 1. So here modulus Z is R1 and modulus W is R2. So it means R1 into R2 must be equal to 1. Now we are also given arg Z minus arg W equal to pi, and here arg Z will be theta and arg W will be phi. So we can say that theta minus phi equal to pi. So this is equation number 1. Now we consider Z bar W. So Z bar means R1 times cos theta minus iota sine theta times R2 times cos phi plus iota times sine phi. R1, R2 equal to 1. So we will be left with cos theta minus iota sine theta times cos phi plus iota sine phi. Now we multiply. So what do we get? We get cos theta cos phi plus sine theta sine phi minus iota times sine theta cos phi minus cos theta sine phi. So this can be written as cos theta minus phi minus iota sine theta minus phi, but theta minus phi is pi, so cos phi here in our question in the beginning it was pi by 2. So here we can make some changes, pi by 2, pi by 2. So this will become cos pi by 2 minus iota sine pi by 2. And we know that cos pi by 2 is 0 and sine pi by 2 is 1. So our answer will be minus pi. Now let's see next question. Question number 2. It says if 1 plus iota divided by 1 minus iota whole power x equal to 1, then what is x? Let's consider its solution. So 1 plus iota divided by 1 minus iota whole power x equal to 1. We can rationalize it. So 1 plus iota times 1 plus iota divided by 1 minus iota times 1 plus iota whole power x equal to 1. So 1 minus 1 plus 2 iota divided by 2 whole power x equal to 1, which further implies iota power x equal to 1. And we know that iota power over n is 1, where n is any integer. So x must be 4n, which is our answer. Let's consider question number 3. The question number 3 says, suppose z and w are two complex numbers such that z bar plus iota w bar equal to 0 and arg zw is pi, then what is arg z? So let's see. So we write z bar plus iota w bar equal to 0 or z bar equal to minus iota w bar, and we take complex conjugate, so it will become z, and complex conjugate of iota will be minus iota, so it will give iota w. From here we can get the value of w equal to z upon iota. We can multiply by iota both sides, so hence we get minus z I. So w equal to minus z times iota. Now we consider arg z w equal to pi. So arg z w equal to arg z is z, but w equal to minus zi. So z into minus zi, which is equal to arg minus I times z square, which can be written as arg minus iota plus twice of arg z. But arg zw is given as pi, so we can write it as pi. And arg minus I, here it is cos pi by 2 minus I sin pi by 2. So arg is minus pi by 2 because cos of minus pi by 2 and plus iota sine of minus pi by 2 will give cos pi by 2 and minus iota sine pi by 2. So here it will be minus pi by 2 plus twice of arg z equal to pi, or twice of arg z equal to 3 pi by 2, or arg z gives 3 pi by 4. Which are answers? Consider question number 4. Question number 4 says, if z equal to x minus iota y and z power 1/3 is equal to p plus iota q, then x upon p plus y upon q divided by p square plus q square each. So we consider z equal to x minus I y, which is equal to, from here it is given that z power 1/3 equal to p plus iq. So what we can do, we can write z power 1/3 equal to p plus iota q, and we cube it. So we get z equal to p cube plus I cube q cube plus 3p square I cube plus 3p I square q square. So this will give p cube minus I q cube plus 3p square q times I minus 3pq square. But z is given as x minus iy, so we can compare real and imaginary parts. So we get x equal to p cube minus 3pq square, and y equal to coefficient of minus iota on both the sides. So that will give q cube minus 3p square cube. Now we find x upon p from here. So that is p square minus 3q square, and y upon q from here. So that is q square minus 3p square. So we put these values here. So x upon p plus y upon q whole divided by p square plus q square. We will get p square minus 3q square plus q square minus 3p square divided by p square plus q square. It will become minus twice p square plus q square divided by p square plus q square, from where we get minus 2. So this is our answer. Consider question number 5. Question number 5 says if z square minus 1 modulus equal to modulus z square plus 1, then show that z is situated on imaginary axis. So let's consider its solution. It says here we know that z equal to x plus iota y. So we can write z plus iota y whole square minus 1 modulus equal to x plus this x plus iota y, sorry. So x plus iota y whole square plus 1. So we can expand it, x square plus 2xy iota minus y square minus 1 modulus equal to x square minus y square plus twice of xy iota plus 1. Now, here it's given, this is square. Square means we have to write its modulus value. So instead of writing this all, we can write its modulus value. So that will be x square plus y square only, because modulus value, modulus z will be equal to root of x square plus y square. So plus 1. Now, if we take modulus value of this side, so we get root of x square plus y square, sorry, x square minus y square minus 1 whole square plus 4 x square y square equal to x square plus y square plus 1. Now we can square both sides. So x square minus y square minus 1 whole square plus 4x square y square equal to, here a plus b plus c whole square is a square plus b square plus c square plus 2ab plus 2bc plus 2ca can be applied. So it will become x power 4 plus y power 4 plus 1 plus twice of x square y square plus twice of y square into 1 plus twice of 1 into x square. Similarly, we can expand LHS also. So we can solve it. So it will give 4x square equal to 0, from where x equal to 0. And we have z equal to x plus iota y. So when x equal to 0, then z will be iota y only. So that is why we say that z lies on imaginary axis. Now, next question. Question number 6. Question number 6 says if z1 and z2 are two non-zero complex numbers such that modulus z1 plus z2 equal to modulus z1 plus modulus z2, then arg z1 minus arg z2 is. So Let's consider its solution. So here Z1 equal to say cos theta 1 plus iota sine theta 1. Here modulus Z1 is taken as unity. Similarly, Z2 equal to cos theta 2 plus iota sine theta 2. We also take Z2 modulus equal to 1. Now we consider modulus Z1 plus Z2. That is cos theta 1 plus iota sine theta 1 plus cos theta 2 plus iota sine theta 2 modulus. So here in our question, modulus Z1 plus Z2 equal to modulus Z1 plus modulus Z2. So modulus Z1 is 1 and modulus Z2 is also 1. So it will be equal to 2. Now we can write it like cos theta 1 plus cos theta 2 whole square plus sin theta 1 plus sin theta 2 whole square equal to 2. We can square it. So on squaring we get cos theta 1 square plus cos theta 2 square plus twice of cos theta 1 cos theta 2 plus sin theta 1 square plus sin theta 2 square plus twice of sin theta 1 sin theta 2 equal to 4. Now further, so this term will make 1, and similarly cos theta 2 square here it's like this. This will also give 1, so 2, and then here 2 and this is 4, so 2 will be reduced. So we can write it like 2 common cos theta 1 cos theta 2 plus sin theta 1 sin theta 2 equal to 1 plus 1 is 2 plus 2, sorry, and there's one mistake here. If we look back, so it is from here, this is 4, so this is 1 1 2, that is okay. So now it is correct. So next step will be, it is 2 plus 2 times cos theta 1 cos theta 2 plus sin theta 1 sin theta 2 equal to 4. This 2 can be shifted to RHS. So from here, 2, this is cos theta 1 minus theta 2 equal to 2. So we can divide it by 2. So we get cos theta 1 minus theta 2 equal to 1. And it is only possible when theta 1 minus theta 2 equal to 0. So theta 1 minus theta 2 equal to 0, or org Z1 minus org Z2 equal to 0, which is our answer. Thank you.